Hey Wargamers, I have a question for you, and that is, biologically, what are tau? Now, this is a question that's existed since tau were introduced, but it certainly has become much more popular and much more contentious over the past few years with an increase in third-party models. As those models become more popular, people continuously debate about what morphology we should see on tau and which morphology we should not see on tau. And really, I thought it'd be fun to take a stab at this question. So I asked people on the internet what they thought tau were. And of course, the responses ranged from cow people to goat people to fish people to camel people to things totally different, something other than those. And so today we're going to try to find an answer and take a stab at how we would classify tau if they were real, right? Of course, they're pretend, they're for fun, but if they were real, if they just existed all of a sudden, how would we classify them? What types of words would we use to label them? So let's jump into it. Much of the language that we use to describe different types of organisms has a basis in the Linnaean Taxonomy. And that taxonomy is essentially just a system of categorizing organisms into different bins of various sizes that are more narrow or more broad. And so the Linnaean Taxonomy is comprised of different levels, ranging from domain to kingdom to phylum to class to order, family, genus, and species. And each of those is more specific in that order. So domain is the broadest of these categories. There are 3 different types of domains. There are archaeans and bacteria, and then also eukaryotes. Eukaryotes is the domain that includes things like us, things that have membrane-bound organelles and a nucleus. Within each domain lie different kingdoms. So for eukarya, there is a kingdom Animalia, but there's also a kingdom Fungi and a kingdom Plantae. So animals, plants, fungi are different kingdoms that we can find within the domain. And so on down the line, we have different levels of specificity. So for instance, the American black bear is just one of several bears in the genus Ursus. Polar bears, grizzly bears are also there too. When we get to family Ursidae, we have those bears, but also pandas. And when we get to carnivora, we have those bears, but also other types of carnivorous mammals like tigers. A step up from that, class Mammalia is all mammals. So we have horses and bears and humans and orcas are all examples of mammals. Above that, we have chordates or phylum Chordata, which are generally vertebrates, but not exclusively. Above that, we have the kingdom Animalia, and then above that, we have eukaryotes. So this is a hierarchical system that can become increasingly narrow, but a lot of these words that we've described across these different levels of taxonomy should be familiar to you. You've probably heard of bears before. You've probably heard of carnivores before, and mammals and vertebrates and animals before. And so the words that we use to describe different organisms often are tied to these levels of taxonomy, at least in some way. So we are going to use taxonomy as a way to understand what exactly is a cow, what exactly is a fish or a camel or a goat, and see how that compares to what we know about tau in order to figure out exactly where they might fit. However, there's a bit of a caveat that we have to address, and that is that taxonomy is a construct. It's something that we made up. It's a tool that we use to understand how similar different organisms are from one another. And the exact ways and tools that we use to understand similarity have changed over time and continue to change. But in general, the idea is that things that are within a given taxon are more like one another than things across different taxa. So, for instance, 2 humans are more like each other than a human and a jellyfish, for example, right? Those are different species, and so we'd expect 2 individuals of the same species to be more like one another than 2 individuals from different species. Same goes for each given taxa. So if we go up to the genus level, we expect that different species within a genus are more like one another than different species from different genera. And that goes up the line. And so it's really just, again, a way of saying which things are more similar to one another, but it's also meant to reflect evolutionary relationships. And so if we assume that taxonomy reflects evolution, then we really are acknowledging that all eukaryotes, for example, are related to each other in some way. They all descend from one common ancestor, and that is indeed the prevailing understanding. If that's true, then unfortunately xenos, like tau, fall outside of our existing taxonomy. They evolved on a different planet or a different dimension or something else completely, right? They are independent from the taxonomy that we have established today here on Earth. Our most inclusive level of taxonomy is the domain, which again is things like eukaryotes. And that is still limited to Earth biology. It only accounts for things that have evolved here on Earth from that ancient eukaryotic ancestor. And so in order to accommodate xenos, like tau, we would need to create some new highest tier, like planet or something like that, and have a whole series of lower taxa that fall into that nested design, that hierarchy that we've established under this new broader category of planet. So since tau are divorced from evolution here on Earth, the real answer to our initial question of what are tau is that tau are tau. They are their own thing, just like David asked pumpkins. They are not related to anything on Earth, and so they cannot be fit into the taxonomy that we've established. We can't use words like cow or goat or fish or camel to describe them because they are their own thing. Unless they're not. Unless life was seeded throughout the galaxy, right? If the same ancestors that gave rise to eukaryotes and humans gave rise to things on other planets, then there's actually a link between those different life forms. This could be artificial, it could be by aliens, like for instance the Elder, or it could be natural, like a planet explodes and spreads tiny little cells throughout the galaxy. Again, that's hyperbole. That's stepping into the realm of fantasy and science fiction, but still, like, let's just say, suspend our disbelief for a moment and say that could happen. If this were true, it would explain similarities across life forms parsimoniously with relatively few assumptions. So we could look at organisms in the 40K universe, Tau, Eldar, the various humanoid life forms, and say like, oh, these similarities exist not by random chance, but because they are derived from a similar common ancestor. And if that were true, then taxonomy that we've already established could apply to those new life forms. But exactly how, when, and where that seeding event occurred would influence how the taxonomy responds. For instance, if we took some original cell, kind of the original ancestor of all life on Earth, and had also placed that somewhere else, that would suggest that we still would need to have a planet level of taxonomy. But if we did something a little bit more recent, let's say take the first eukaryote and seeded that throughout the galaxy, then we could fit any descending organisms under that umbrella of domain eukarya. So the whens and hows and whys of seeding throughout the galaxy would actually influence our answer here and change the words we use to describe tau. And so any similarities that we see between tau and organisms on Earth are going to be the same. They're going to be results of analogy, where those traits have evolved independently from one another and appear to us to be similar, but are indeed different things. This isn't necessarily incompatible with taxonomy as a concept, though, since taxonomy itself predates evolutionary thought. The predominant way that we've organized organisms is by looking at what they look like, not how those traits evolved. That type of analysis is a more recent addition to science. And so a lot of things that we call reptiles, for example, are called reptiles just because we decide that's what they look like. And so we can do the same thing with tau, right? We can just pretend that we don't know about evolution, that we're agnostic to the origin of these traits, and instead just look purely at what the anatomy or morphology of tau suggests to us and where we would put them in the taxonomy based on that. So let's pretend that we are in, the 1800s or something and just said, oh, hey, this thing showed up. Where are we going to put it? To do that, we have to look at what we know about tau anatomy. For one thing, we can pretty strongly conclude that they are vertebrate. They have a spine. They have hair, or at least something that appears to us to be hair. They have smooth skin, right? We don't see any protrusions from their skin really, other than what we would see on a human type of organism. We know from a bit in the Citadel skulls box that they have one temporal arch, just like humans do, so their skulls are roughly human shaped, you could say. They have 4 digits on their hands, so they have 4 fingers, and they have cloven hooves and flat teeth. There's also this book called Xenology that was published in 2006, and if this is a question you've looked at in some degree of seriousness in the past, you are probably yelling at the screen, read Xenology. And you're right, there's lots of really good details in that book. It suggests that tau have a ruminant stomach, they have mammalian eyes, they have honeycomb bones that are void of marrow, things like that we could never deduce by looking at the official Games Workshop models alone. The problem is that book is out of print and presumably not canon, so I'm not sure how to account for it. I think it's a very good resource, but we're going to base this discussion just on what we can see in the models. It does include some annotations on the evolution or this proposed evolution of tau, and it uses a lot of the same vocabulary that we are using in this video today, which is good and tells me that I might be on the right track. But we're not going to be relying on that as our guide for this remainder of the discussion. The good news is that a lot of these traits and speculations that it puts forward are pretty much consistent with the other traits, which is good, right? Like, it would be a lot harder to have this discussion if there were, really incongruent features of the anatomy, or if tau were a lot more like a chimera of different organisms, but they are pretty unified in their anatomy. So we're able to proceed with this discussion just based on the things we can observe, and we don't have to take on the burden of using a potentially not canon resource. All right, so sticking just with the anatomy we can observe on the official tau models, we can start to evaluate how well tau fit into some of the groups that people often associate them with. One of those is fish. People call tau fish people sometimes, and so we can look at this list and see how well they fit into the class Actinoparigi, which is the ray-finned fishes, so things like goldfish or walleye. Those are all examples of ray-finned fishes, and tau really don't have anything in common with them. They are vertebrates, just like Actinoparigi, but other than that, all of their traits suggest that they are not part of this group. So we're able to exclude fish people or Actinoparigi right off the bat and start honing in on some more viable candidates. The fact that tau are vertebrate, have hair, smooth skin, and one temporal arch is consistent with them being members of class Mammalia, or the mammals. Yet this isn't a perfect fit because there are things about tau that are inconsistent with Earth biology even still. So, for example, if we were to take Xenology's word for it and say that tau have honeycomb bones and don't have marrow, that's not something true of Earth mammals, right? For example, humans have marrow that is really important for creating and regulating our blood supply. And so the fact that tau don't have this would suggest that they're actually not part of Mammalia. Similarly, the loss of other traits like the apparent loss of mammary glands in tau would be inconsistent with Earth mammals. All mammals have some sort of mammary gland. That's what gives them their name. But that doesn't mean that it's totally impossible, right? It's still possible that tau could realistically fit within Mammalia if these traits were either gained or lost later in evolution. This does happen from time to time. That's why things like the appendix in humans is a vestigial structure, or the limbs of snakes are vestigial or non-existent. You can have that type of loss. Monarch butterflies, for example, have 4 legs, whereas most other insects have 6. That's something that they evolved to have fewer legs over time. And so, too, we could say tau evolved these other traits over time, not in a way that's inconsistent with them being in the class Mammalia, but in a way that suggests a very specific lower taxonomy for them, probably having their own genus at a minimum. And so we look at these other traits for further guidance as to how to narrow down the taxonomy of tau. We see that they have 4 digits on their hands and cloven hooves and flat teeth, but those are kind of inconsistent in earth biology, right? Cloven hooves are generally associated with more cloven hooves and not fingers, right? Like centaurs don't exist and satyrs don't exist in Earth, so it's weird that tau have cloven hooves and 4 digits. So how could this be? Well, to answer that question, we are going to have to talk at least a little, maybe a lot, about feet. I mean, hooves. It's not that kind of video. We're not talking about feet. We're talking about hooves. Animal hooves, to be particular. So congratulations. This is a hoof video now. Hopefully that's your thing, because we're going to talk about it. Right. So hoofed mammals are called ungulates, and they can either be described as even or odd-toed. Even-toed ungulates are things like bison and cattle, where they have all their weight resting on 2 hooved toes on each foot, whereas odd-toed ungulates are things like rhinos or horses, where they have all their weight resting on 1, 3, or 5 toes with hooves. So yeah, even or odd-toed, pretty straightforward. But all ungulates, regardless of whether they are even-toed or odd-toed, evolved from animals that had 5 toes. And so we end up in this situation where both even and odd-toed ungulates generally have lost some of their digits over evolutionary time. And so it's not impossible for an ungulate to have 4 fingers, given the fact that it evolved from something that had 5. Just like the monarch butterfly lost 1 set of legs, so too could have tau lost 1 finger. So tau must have lost more digits in their feet than in their hands, and then subsequently evolved hooves in their feet, but not their hands, suggesting that tau first evolved this differing number of digits, and then subsequently evolved hooves in those lower appendages and not in their upper appendages. So a little bit of evolutionary theory wrapped in there in how tau ended up having hooves but not on their hands, and exactly why they have 4 fingers as opposed to 5, or just, hooves in general. Okay, so with that little detour, we have already established that tau are likely part of class Mammalia. And our observation that they have 4 digits on their hands, cloven hooves, and flat teeth suggests further specification, and that they are probably some sort of ungulate. But what kind of ungulate? Well, if we look at the models, we see that they have 2 cloven hooves, so that means that they are part of order Artiodactyla, which are the even-toed ungulates. Within order Artiodactyla, we have family Bovidae, which are ruminant ungulates like cows, and also family Camelidae, which are ungulates with padded feet like camels. But there are a couple things about camels and Camelidae that suggest that tau are not part of that family. For one, if we look at camel feet, their feet are not really that hooved. They have kind of just little toenails on them, not full hooves like we see on tau. And if we look at their teeth structure, they actually have some sharpened incisors that can be pretty darn nasty. Tau don't have any type of sharp teeth, so the fact that camels have these weird toes and these weird teeth mean that tau probably don't fit in that family. So if we're just left with bovidae, then we have subfamily Bos and subfamily Capernae as two potential subfamilies that we can further specify tau to. So let's evaluate these two options. On one hand, we have Bos, which are grassland bovid, like cattle, for example. They are adapted for a relative life of luxury. They're adapted for fertile grasslands where there is ample food and not a lot of strenuous physical activity required of them in order to conduct their day-to-day business. For this reason, Bos contain some of the largest ungulates. They are able to grow to these relatively large sizes because of ample resource supply and not a lot of physical demands other than, being alive. So they're able to get pretty darn big. They also have clear sexual dimorphisms, meaning that if we look at bulls versus cows, we can see physical differences very plainly. For example, bulls might have horns, whereas cows have udders. We can see that sexual dimorphism being very present in Bos. In contrast, Capernae are extreme bovid. They have many different traits that separate them from Bos. For example, they are adapted for a pretty rugged lifestyle, generally living in places like tundra or mountains or deserts where just getting from place to place can be quite a challenge. And there isn't a lot of food, right? So in places where they don't have a lot of food, it is highly advantageous for them to be relatively small. They don't have the caloric intake to support a large body mass. In addition, they don't display overt sexual dimorphism. They are pretty similar between males and females. For instance, if we look at goats, both of them have horns. And so that lack of sexual dimorphism is something that we see in Capernae but don't see in Bos. So when we lay it all out like this, I think there's a pretty clear, strong argument to be made for tau belonging in subfamily Capernae. They are adapted for environments that don't have a lot of resources, just like Capernae. They are relatively small, like Capernae, and they don't have clear sexual dimorphisms aside from, their cranium. So, again, consistent with Capernae. All these things make me suggest that, tau are, in essence, Capernae or goat people. This means that I think if we were to fill out the full taxonomy for tau, we would do something like this, where they are in domain Eukarya, kingdom Animalia, phylum Chordata, class Mammalia, order Artiodactyla, family Bovidae, and subfamily Capernae. And then there's the question of genus and species. I think we are stretching taxonomy pretty hard just to get tau into a subfamily. So we probably would just have to create a new genus and species for tau. There is a silver lining to this cloud of ambiguity at the end here, though, and that is that all castes can interbreed, biologically speaking. In the fluff, they can physically do it, but they're just not allowed to by the ethereals. So at least the four main castes are therefore biologically the same species, since they can interbreed and produce viable offspring. So that's good. That means that we don't have to create either subspecies for the different castes or suggest that the different castes are different species within the same genus or anything like that. So that's good. That's a little bit more simple. At least all tau are, tau. So that's good. So in conclusion, what are tau? Well, tau are aliens, but they present morphology that is analogous to many of the traits possessed by subfamily Capernae on Earth. Right? So they are their own thing, right? But if we were forced to use our Earth-based vocabulary to describe them, we would call them goat people. Yep, goat people. That's my conclusion, and I'm sticking to it. I know there are lots of people that have made a similar argument and come to different conclusions or something like that. But I don't know. I think this fits. I think it fits, and I would really love to hear your impression and your conclusion in the comments below. So let me know what you think. Am I right about tau being goat people, or did I totally miss the mark? And they are clearly kangaroo people, right? That's the deal. I totally missed the kangaroo angle on this, and I apologize. Let me know in the discussion below. And as always, thanks for watching and happy wargaming. Hey everyone, thanks for watching. A while ago I made my own miniature, and if you too want to be the proud owner of an invasive wargaming model, you can check out the link in the description below. Down there you will also find links for the Invasive Wargaming Discord server and the Invasive Wargaming Patreon. Really, this channel wouldn't be possible without the support of my patrons. Special thanks to Marcy, A Little Pink Monster, Bennaby Jones, Durza, Ever Keller, Robbie Goodwin, Jose Gomez, Ruger, Drew Pratley, Michael Byrne, Zealous Brimstone, Scott Heater, Stephen Cowan, Jared Egler, Chris Kessler, and Tao Oswell.